สวัสดีค่ะ Welcome to Thailand today. I'm Kusuma Yotasamut. Road network in Thailand covers more than 300,000 kilometers. The Highways Department is in charge of maintenance of 64,000 kilometers of roads and 42,000 kilometers is supervised by the Department of Rural Roads. Maintenance is essential in order to preserve the road in its original condition, protect the user safety, and provide efficient, convenient travel along the route. In Thailand, surveys and maintenance is a time-consuming process and often marked by inefficient evaluation due to erratic human judgment. In Thailand, a prototype road survey vehicle made its debut in 2005. Several more prototypes were developed, courtesy of funding from the private sector, the government, as well as the Department of Rural Roads. Thailand today will speak to two engineers from Chulalongkorn University's Faculty of Engineering who are responsible for development of a road survey vehicle or ROSI car. Here with me are Associate Professor Visanu Sapsompon. He is the head of Infrastructure and Transportation Research Cluster, and Associate Professor Dr. Paisan Santitham Manon. He is from Department of Survey Engineering, Chulalongkorn University. Please join me to welcome Associate Professor Visanu Sapsompon, Head of Infrastructure and Transportation Research Cluster, Faculty of Engineering. And also we have Associate Professor Dr. Paisan Santithamnon, Department of Survey Engineering, Chulalongkorn University. สวัสดีค่ะ Welcome to Thailand today, sir.
My pleasure.
Well, today we are talking about ROSI. But ROSI here is not beautiful, but useful. So we have to come back to you. Why do we need, that's we're talking about just to the audience at 177 countries. Look at this and you will wonder why do we have to talk about ROSI because of the road network in Thailand, see the condition of the roads, right?
Right.
So tell me, first of all, Professor Visanu, why do we need, how is the situation of the road in Thailand?
Well, as a road users, we expect that the road condition must be very good.
Okay.
That's what we expect from. But we have to understand the constraint or limitation of the highway agencies. Because in the past, when they prepare for road maintenance budget, we need the data on road condition.
Oh,
Okay. But however, in the past, they must rely on the data from the on-site inspectors,
Okay.
which is, they walk through the road and collect to measure the road damage. Yeah, it's very time consuming, right? So that the limitation comparing to the whole road network of more than 100,000 kilometers. So that's their limitation. So our research goal is designed to develop a tool to help them collect data more efficiently in terms of speed, faster, the data, the accurate, and cost efficiency. So we develop a tool called ROSI, which stands for Road Survey Vehicle.
Be careful, we go to the door. But anyway, so this is the interest of yourself or Chulalongkorn University as a whole?
I think as a group.
As a group?
Yeah, because at a research group.
Okay.
Because at university we set up infrastructure research group because we think that Thailand, still in developing countries. So we need to develop a lot more infrastructure.
You're right, because but Thailand good names. on about the road infrastructure mostly, but don't go into the soil. That's another problem. But
Right.
what you're talking about, the research being done by your team, is meant for Bangkok only, or what, or rural?
Yeah, for the whole nation.
For the whole nation. Oh,
Right, for the whole
that's good.
nation. Yes.
So this is the interest
Yes.
of doing so. What, all of a sudden you sit down and say, okay, let's do this. What? How did it come into reality?
Well, we have done this for almost a decade.
Oh, really?
Yeah, for more
Oh.
than 10 years, and we got colleagues, got peers who have the same interest. So that where it come from, research group.
Yeah. So you may like to see how his rosy look like. How it is looking like? It's pinkish.
You mean
The car, the Rossi
vehicle? Okay.
itself.
The Rossi is a vehicle, a modified vehicle that
Okay.
houses many equipments. For example, we have a front view camera to collect the access view while we are
Okay.
driving.
Okay.
Okay, we have a live scan camera at the back of the vehicle to collect a pavement picture.
Oh.
Yeah, to see the damage of the real condition. We also develop, we call it bump indicator to measure the movement, vertical movement of the car axles, because this data reflects the roughness of the road or riding quality.
It must be really strong because we care about our car when you get bumping.
Yeah.
You see, but this must be very, what you call
Yes.
it? I don't know what is
Robust,
technological
it's robust,
about-
yeah.
It must be very efficient, and you may like to see. This is the actual one, right?
Yeah. That's the first version.
This is the first version.
Yeah.
So how did it go with the first version? Okay, I mean.
Yeah, it's okay. Right now,
efficient.
actually, the Department of Rural Roads use this car for like 16 vehicles already.
Oh.
They're in real operation.
I was about to ask you how many
Yeah.
have been producing.
Yeah, 16 for Department of Rural Roads.
16 the rural.
Yeah, and one for Department of Highways.
Okay, so you don't produce.
No, yeah, we
you
license
only-
technology.
You license the technology
Yeah,
to whom?
to the company,
To the
to spin-off
whoever-
company.
Okay, so they're really interested.
Yep.
It's private.
Yeah.
It's a private company.
Actually, we call it spin-off company because the founder of that company, they were postgraduate student from our lab.
Oh, okay. That is good because being a professor, being the lecturer yourself, so this is meant to for the benefits of the student
Yes.
also, right? Oh, okay.
Yeah, that support the current policy of the Ministry of Education into incubate students, to spin off company from the technology that has been developed in the university.
The spare parts and everything, it is from Thailand locally or?
Some,
It has to be
but
some-
most high-tech equipment, of course, we have to import. But that's just for the hardware.
Okay.
But
yeah.
most research which have been done, we focus on the software, the software parts, because it's very important for software.
Professor, can you go a little down? Tell us more about this. So what inside? How do you say the software? I see computer here, so I don't know how does it work. Inside, is it in the car? Can you tell me more about this, please?
Right. We have a various software inside that.
Yeah.
For example, we have a software to help to detect pavement crack automatically. After we
Pavement
drive,
crack,
yeah,
okay.
we get a picture.
Okay.
Then the computer say we knows that how many
Wow.
crack on the road,
On the road,
on the pavement
okay.
automatically.
Oh.
That the software that we do. Another software that we have developed is to detect texture depth. With this data will help us to detect the pavement, the area of pavement which has insufficient friction. Friction is also important in terms of safety. Another software is like we developed to measure the radius of curve and super elevation in order to identify the area of the danger curve when comparing to the speed that we use.
Oh, okay.
Yes, that we have been done in the past. But for the state of the art now, we have to ask Dr. Paisan. He's the head for
on that so now come to you, Dr. Pam, because we really need to know, because this is something new. It's never ever happened in our country, in Thailand, right? It's the first time.
Yeah, it's really going to be a very first system that we Thai have developed, such kind of automatic inspection vehicle, let's say. Yes.
So you have to tell us more about that.
Yeah,
Why do yes.
The ongoing from lossy system, we try to improve the quality of the system and efficiency of the system. So the current technology we based on so-called mobile, for example, mobile mapping system.
Mobile mapping, how it is like?
MMS. Mobile mapping system is still
moving.
It's still moving. It's still a vehicle-based system. We put a precise positioning system inside the car. This actually in the public mostly do, for example, GPS, global positioning system. But we have quite a sophisticated and high quality GPS receiver. So this vehicle, once it goes on the road, it can identify itself position very accurate, something like a centimeter or even millimeters, for example. And beyond this positioning system on the MMS, we put many sensors.
Sensors for that.
The same as lossy again. We put something like a video system that can make the photographs 360 degrees around the vehicle.
The
vehicle. So we can capture the environment picture very quick, right, and very complete. And it's go like this every meters on the road. And beyond that, we also put some other sensor. It depends on the missions. Some mission we might need, for example, laser scanning. We put a laser scanning on the vehicle, and this laser scanning, it go round and round all the time during the car driving on the road. So we can capture not just the quality of the pictures of the road and road size, but we also get the quantities. That means we can measure. We can take a look at the, for example, safety sign. We can see how the poles or the traffic sign is still in good condition, for example, in good shape, for example. This is the current situation for road inspections.
How much is it one? Was it very expensive?
Of course, it's a high technology.
It's very high technology.
It depends on the parameter of what kind of information we would like to get. It could be start from some simple system, starting from something like a few million Thai bahts, up to perhaps $1 million.
It's worth it.
For example.
To have a good road.
That's for the MMS technology. It's similar like a Google Street View.
Google Street View is a kind of MMS.
Same technology
that we can see.
But if we talk about the low-C, the first version, the cost we try to make, it costs like about 1 million. Less than
well, it's worth it, because anyone buying for 1 million, and it just can go to
exclude the car, excluding the car, depending on the type of vehicle.
Professor, let me get back to you. The what you call the outer part? What you call the body? Is anybody can be used, or is just a particular body of the vehicle?
I see. Yeah, well, the vehicle that might fit for MMS, actually it could be
anything,
any kind of the car. Important is that we can put the equipment, and high-tech equipment nowadays is quite small. Something like a GPS receiver, it could be something like so small that you actually in your mobile phone already.
Really?
You have one. You should have one. And some other sensor, sometimes it might a bit bigger, that anyway we can put on the top of the car, and we put some operator inside the cars. Some mission we need 2 men, some mission we might need 3 men. So the car is not special. The car is not special.
Oh, but there's someone there.
Yes, sure.
It's not.
Sure. We need at least
not
one
like
driver.
robotic.
No, not yet. Not yet.
To my understanding, I thought it's robotic type. No, it's not. So to make clear to the audience that this particular equipment. What do you call? It's being
Yeah.
placed permanently. The
Mobile mapping
you call
system,
mapping system.
MMS, yes.
MMS
Yes.
is permanently placed in the car,
Yes.
and then
sure.
just one seated
Yeah.
somebody to drive on.
We install in the
particular-
car, sure. But nowadays, vehicle we still need driver anyway. But in the near future, or we have see some sample in US, in Europe already, right? Or in Japan, they're starting with the research with unmanned vehicle.
Unmanned,
Right?
yes. So this is involved mainly at engineering faculty of Chulalongkorn University.
Yeah, but several disciplines, several disciplinaries. Like for example, I'm from civil engineer.
Yes.
Yeah, I'm from civil engineer. Professor Paisan from Department of Survey Engineering.
Yes.
We also work with a few colleagues from several departments. Department of Computer Engineering.
Thailand has produced a lot lately, young entrepreneur, young engineers. I mean, very good for a competition with other country. How is it now? I mean, for this mainly concerned on this part. What is the production of the engineering from Chulalongkorn University?
Well, I think it depends on disciplines. For example, if you are in information technology,
Yes.
it's a bit easier to start up
Yes, sir.
their companies or entrepreneur. But if you work in if you are chemical engineers, it's a bit difficult to start your own business based on what you have done in research.
After this, after the car, what else you going to do for, only road that you were mainly concerned or anything else?
Well, actually, infrastructure that we
The whole
no,
infrastructure.
the whole
Ah,
infrastructure.
it's very important.
Railway is coming.
Oh.
Yeah, we have done railway inspection.
Please do something on railway.
Yeah.
So we could see the derail sometimes.
Yeah, there are problems.
Yes.
We have a colleague, Professor Bunchai, is doing research on this one.
Very interesting. That's also part of Chulalongkorn Engineering.
It's our team in.
Look at the picture here, Professor. It looks like big, and it's not moving very easily or like old-fashioned. I can say that.
Okay.
Will you do any development
Okay.
on that or anything?
Sure. This kind of vehicle, we have to install many equipment.
Oh, that's right.
So it might be weighty, but anyway, we can drive this car like a normal car, even up to some configurations or some system. We can even drive up to 100 kilometers per hour to do the survey. So it's, as I told you, it depends on the missions. What kind of parameter we would like to see, or what kind of road damage we would like to measure, and so on. So it depends. It depends, of course.
So that means it's movable.
It's movable, of course. Important is mobile. Mobility is important. Otherwise, we could not get information for the whole network for Thailand.
Yes.
100,000 of kilometers, as Professor Visu
We
said.
have 300,000, right?
300,000 for the whole road, but for the national highways, which are under supervision of Department of Highways and Department of Roads, comprised of 100,000. Yeah.
What is the next project?
Well,
Drone.
Yeah, drone. He's working on it.
Yeah, the information from road conditions, if we get today, next year, it will be outdated, right? It changes all the time.
Yes.
So we have to keep up with this kind of changing. So change detections will be, of course, will be the topic, and how we can, it's still always the question, how can we get information more rapid, right?
To your experience, what kind of safety of the road safety it should be? Because at the moment, there's a road passing to, I think somewhere in Paramka nearby our district. It's like this, and another part is like slanting like this. It's been like this for years. Nobody done it. So what's happening? What can you do? That's kind of thing that you are mentioning. Also part of it, sir.
No. I think it's belong to the local road, local authority.
It is local,
right.
but that also can, you have to enhance with what we are talking about. It can be the way. Supposing you're driving that, I've been passing, so I'm going to passing that, and you can know what's going on there.
Yes, because we have a camera.
You have a,
With the camera, yes.
Very interesting, very nice. I could see here how about this? This is what?
This
This
are
is the, this is what,
Yeah,
sir?
this is a one of instrument that we have so many kind of device here,
Yes, sir.
and this one of that so-called DMI, distant measuring instrument. That means we can measure the distance that when we drive along the road,
Okay, sir.
very accurate.
Oh.
Just example,
So each
and
and
this
every-
data will be fed directly into computers.
Each and every part being produced, being innovated by you people, by the student, by yourself?
But for hardware, actually not every part. We integrated. We
Okay.
integrated.
Integrated.
We evaluated what kind of device or instrument will be qualified for this kind of mission. We integrated, but we need some engineer to design and integrate it and put on the car and test it and run the system.
Right. To make all equipments talk each other.
Or do they?
to,
Do they
Yeah,
talk?
yeah.
to synchronize. I'm sorry.
To work together.
To
let's
work
say.
together.
To work together. Let's say.
Oh,
For
very
example, for the camera, we bought camera, but how,
So the,
how
your usual camera, or what? Or any
it's
uniqueness?
unique camera is really
Sure.
Special one.
We need some specific camera.
special
camera.
camera, but
For
how to work with the DMI? Yeah, we have to write a software. How the camera talk to understand the distance that the camera
Professors,
is
I'm a
moving.
layman. So you buy each one. You buy camera, you buy sensoring,
Yeah, yes.
you buy and then assembling together.
Yes,
Is that
exactly.
right?
Yes,
Oh, that's easy. That's cheap.
No. Putting together is cheap, right? But making talk, or we call
Making them
to
talk to each
understand
other.
each other.
To
That is
understand
another
each other.
this
That's
is
another
the
thing. Yes,
problem.
sure.
Yeah.
That's another thing.
Yes, very interesting and very nice to know this because at least some group of people put together think about what to do with certain normal human beings' life daily. So one last question for you, Professor. What are the benefits of the ROSI Corps?
Well, the ROSI provides information that help to making for management, for road planning. For example, like if we want to estimate how much budget do we need to maintain road in good condition. So we need this kind of data, right, in order to estimate the budget that we need. And if we have limited budget, it's always the budget constraint. Is always how can we prioritize
Okay.
which project or which road should get to fix first. Because
So
we got the data of the actual data of road, the real condition.
So for Professor Praisan, the what do you call the car repairer do not like you because
Why?
Because the road is already going to be good
Yeah,
and then
yeah.
nothing to repair.
Yeah.
Yes.
But anyway, I think road safety, everybody
Need
need
it.
it. Sure, we need it anyway.
Exactly. I have a minute for you. You want to say anything more?
Yeah, Chulalongkorn University, we aim to providing the technology, anything that we could tell the public to make it better. So we try our best.
Yeah. So keep on with your good jobs.
Yep,
Thank you. Well, Thailand Today appreciates the time of Associate Professor Visanu Sapsompont and Professor, he's from the Head of Infrastructure and Transportation Research Cluster, Faculty of Engineering. And we cannot go without thank you to Associate Professor Dr. Paisan Santithamnon, Department of Survey Engineering, Chulalongkorn University, spent with us and told us on a new technology in road survey and maintenance to keep this Thai road safe for all motorists. Thank you very much for being here. Thank you for watching Thailand Today. I'm Kusuma Yotha Samut. Hope to see you again, same place, same time here. สวัสดีค่ะ